Here. Yesterday they put the ice in the radio.
What'd you roll over in your sleep for? Where's that other chucklehead?
Hey, fellas! Hey, fellas! I'm stuck! Defrost me!
Welcome to Did You Know? The ESCO HVAC Show. We will see you in about 45 seconds or so. Make sure that you are subscribing to our channels, our LinkedIn, YouTube, Facebook. Turn on notifications, and we are very excited to be here with you. It's almost time, about 30 more seconds. Make sure to grab your notebook and pen so you can jot down notes along the way, because at the end of the show, you could have an opportunity to ask our guests questions so we can dive a little deeper into these topics. And here we go. Welcome to Did You Know? The ESCO HVAC Show. Thank you all for joining Did You Know? The ESCO HVAC Show, brought to you by the ESCO Institute. My name is Clifton Beck, and we've been spending a lot of time talking about changes in our industry, new regulations, implementation of new equipment and refrigerants, and we want to dive a little bit into some of the technology that we're going to be seeing over this next couple weeks, months, years. The evolution of our HVAC industry. And we're grateful to have guests of the industry joining us. So we have Christian Valoria, Jamie Kono, both building science engineers from PNNL, Pacific Northwest National Laboratory, and we're going to discuss some of the incentives and the opportunities that are coming to us through the DOE through things like the Inflation Reduction Act. So what are we talking about with the Inflation Reduction Act? Many people are unaware of how important, how impactful this is to the world and to the industry. Well, it is one piece of legislation that has been signed that is going to bring about a significant amount of investment into change in the way that we utilize energy. And this is a piece of a worldwide effort to reduce our total CO2 emissions. Right? So we're all playing a part in the global reduction of greenhouse gases. Now, we are going to see some transitions in our industry due to this. It's been inevitable. Anyone who has really been around the automotive industry has seen that it's been happening there for decades. When we started the initiative to reduce CO2 emissions in the automotive industry, it was pretty drastic, pretty quick, and we are continuing to make changes in increasing the efficiency of our automobiles so that we can decrease the CO2 emissions. Now, what about the HVAC industry? Well, we talked about this a few months ago. We have been making some changes in our SEER requirements, and we've gained a little bit of momentum on that, but not as significant as it could be. Well, when we look back at what happened with the automotive industry, we took out things like carburetors and points ignition systems and timing chain-driven timing systems to go with things like fuel injection, electronic ignitions, and variable valve timing, right? Starting to get variable capacity out of our systems, our pieces of equipment. Well, when we talk about HVAC, we're going to start seeing some similar things in the HVAC industry. A lot of us have already noticed those. We've been moving away from things like fixed orifice pistons and contactors and single-speed motors, going with things like thermostatic expansion valves and electronic expansion valves that utilize control boards and variable capacity compressors, right? Inverter-driven systems. So we're going to spend some time today looking at how these inverter systems are bringing the efficiency to our industry and how things like the Inflation Reduction Act are going to make it a little bit easier for us to look at these transitions, because we're going to see a lot more heat pumps and especially cold climate heat pump technology. So we need to be prepared for that. And we can now talk about how we can make that a little easier on the budget, little softer cushion in the wallet. So Jamie And Christian, we thank you for joining us, and let's talk a little bit about what the DOE is doing for us through the Inflation Reduction Act.
Sounds great. Thanks, Clifton. Yeah, so I wanted to get started by just talking about one of the newest actual incentives that's out right now. This was just announced by the energy.gov earlier in December.
Right.
And so this is a up to $2,000 tax credit for heat pumps. Also includes heat pump water heaters. So we'll cover 30% of the cost, up to $2,000. And yeah, it's something that's available right now. It's through the, I'm pretty sure it's through the Inflation Reduction Act. And yeah, can be used right at the moment.
So up until now, like through 2022, we did have some incentives. We had a $300 incentive for heat pumps, for geothermal heat pump installations, and now that for biomass stoves and heat pump water heaters. But now we're talking about a 30%, up to 30% of the cost of installation, up to $2,000 per year. So a pretty significant change in the way that we're going to be applying tax credits towards our HVAC equipment.
Yeah, and also, this table we've copied it from the DOE, but it's also just for the heat pump side of things. But there's also a lot of other efficiency rebates available for insulation, for windows, upgrading your electrical panel, all of those kind of things, because we know that it's really important to look at a home holistically when you're doing these kind of retrofits. And if you do enough weatherizing or efficiency improvements, now you don't need to put as large of a system in. So very, very helpful all around.
And that's something that a lot of our contractors are going to have to look at going forward is, we've had a lot of inefficient systems for decades, and we're starting to understand the importance of doing, package analysis, looking at the envelope of a structure to see what we can do to make improvements for that, right? We're starting to see a lot more, duct and envelope testing, blower door testing. We're starting to see the demand for efficiencies. We now have states and jurisdictions that are requiring blower door testing on new constructions to validate how tight the system is, and gives us the opportunity to potentially reduce the BTU load that is on the structure, so the capacity of the structure. So if we look at that and we start with, okay, what is our first steps? Are we just replacing a piece of equipment, or can we look at all of the options that we have? I highly recommend doing energy audits on our structure. We had no incentives up until now to do energy audits, but now we're looking at a 30% of the cost, up to $150, to do a home energy audit to be able to assess, are we in a position where we can look at other home improvements? Because now if we're looking at a heat pump, especially a cold climate heat pump, what else can we add? So if we start with a home audit, now we've got incentives to be able to put towards a home audit. And if we look at that home audit and we assess that, hey, maybe our windows and doors aren't up to snuff. We've had some incentives in the past. Exterior doors, we could do up to 10% of the cost. Now we're talking about up to 30% of the cost for our doors, up to $250 a piece. We've got windows that now has a 30% of the cost, up to $600. We have insulation materials that went from a 10% rebate now into a 30% rebate. We have electric water heating solutions, a variety of different things to help increase the envelope of the structure, all being brought through as tax incentives from the DOE. As an HVAC contractor, that is a lot of opportunity when we're looking at a house, because in the past we have been HVAC contractors and HVAC technicians. Well, now the responsibility is really going to start falling on us to analyze a home a little bit more. We may not want to get into home energy audits, but it's a great recommendation to be able to bring one in to analyze a structure to see if we can reduce the capacity of our system.
In the past,
agreed.
Clifton, I would say that, again, when you get into the colder climates where fossil fuels are used, such as propane or natural gas, we could overcome certain deficiencies in the envelope because there was such a high temperature difference between the outdoor air and the indoor air. I mean, that gas furnace is putting out some some really
A lot of
high
BTUs.
temperatures, right? And if we're going to have success moving forward, transitioning into, again, cold climate heat pumps, one of those paths to success of that unit in that structure is going to be to look at the entirety of the structure, the envelope, the duct, those sorts of things, again, to ensure that this system, one, we can downsize it a little bit, and two, it's going to be successful in this situation. The homeowner is going to have a good experience.
Yeah, because what if we had never had our entire electrical system sized for doing electrical heating capacities? What if we were only gas? And now we're starting to look at a home and go, wow, maybe we need to reanalyze to see, because maybe I really want to go with a cold climate heat pump. And we've been talking about it for a while. Now we've got incentives. You know, the old system is really starting to wear out. It's time to think about what we can do. Well, if we have to have any kind of upgrades into our electrical service, we didn't have anything before. Now we've got a 30% of the cost up to $600 for electrical panel upgrades. So we're looking at the entire structure and adding a lot of funds available for homeowners to do improvements on their residence.
We can also identify any deficiencies in the structure that may have been hidden or not as obvious by having that gas furnace there.
Exactly, because in the
where
past,
we're wasting
it's
energy,
just ran.
right?
Yeah,
right. It kept up, but how much energy were we wasting?
Yes. And, you know, especially on our older homes that are natural drafted systems and have poor ventilation, poor windows, poor doors. Now we can really make an impact to our total CO2 emissions by improving our structure. And we've got incentives for doing that.
Yep. And there's a comfort aspect to that as well. You know, sure, you can crank your gas furnace to really hot, but if there's a draft coming in the windows, your feet are still going to be cold by the windows.
Exactly.
Well, there's such a difference in temperature between the time the furnace turns off and the time it turns back on again. There's just this huge swing where there's that uncomfortable, like you said.
Glide gets really wide.
Right?
Yeah.
And that was one of the...
Oh, sorry about that.
No,
I was
go ahead.
going to say, I'll bring one thing up about comfort as well, because part of my work involves windows.
Yeah.
So if you have a single pane window and you're putting in an air conditioning system to condition the space, say for instance it's in the summer, you have sun outside, it's in the afternoon, 72 degrees outside, you want it to be 72 degrees in your home. If you have a poor performing window, you're still going to be uncomfortable, even if you're blasting cold air into that room. So,
Absolutely.
As an HVAC contractor, if you're really, what are you actually providing? It's comfort.
Comfort.
So you do want to really pay attention to the building shell when you're thinking about what you want to do for your customer.
And even for the contractor, we've seen a change from HVAC sales into a new classification of salespeople that are comfort consultants. So we're seeing a lot more comfort consultants in the industry, and you're right. It's there to analyze what the structure is. Let's look at the total shell. Let's see if there are other things that can be improved so that when we leave, you have a more comfortable home. So really glad to see that we have so many things changing for incentives for basically our contractors. All right. Anything we want to touch on this one before we move on to the next slide?
I did real quickly wanted to point out, other energy efficiency upgrades. Clifton, you mentioned, potentially switching from a gas-fired system to an electric heat system, and the circuitry might not be enough. The service might not be that. So that's specifically why they have in here, electric panel or circuit upgrades for new electric equipment. Kind of thinking about that decarbonization goal, potentially switching from gas or oil to electric or heat pump systems.
Yeah. We've seen a lot of homes that were built with the 60 amp service panels, back in the 1940s, 50s, 60s, 70s, into the early 80s, that really weren't designed for an electrification movement because of the cost of utilities at the time. Where natural gas on 60% efficient furnaces was the primary heating source. And we're not going to be able to justify that going forward. We're going to have to improve the efficiencies of our homes, and this is where we start. Very good. All right, well, let's look at how these incentives can develop and how we can add these incentives to really start bringing some big numbers into perspective.
Yeah, so we talked about the incentive that's here right now. There's another part of the Inflation Reduction Act that is still getting rolled out. It's the HERA, High Efficiency Electric Home Rebate Act. I believe that's the letters in the alphabet.
Good
soup
job.
there.
Nice. Yeah.
Yeah, did my homework before this. So this is going to be implemented by the states. It is a voluntary program, so it's possible that not every state will use it. But
I see.
the idea behind this is this will provide point of sale rebates on various electrification equipment, including heat pumps, including electrical upgrades. You see, there's a $4,000 up to $4,000 rebate for breaker boxes, $2,500 for electric wiring, plus $8,000 for a heat pump, all up to a max of $14,000. And I really love this program, and I hope that it is very successful because it's not a tax credit; it's a rebate. So,
up front?
Yeah, so you don't have to shell out all that money for the system, then wait to get it back when you file your taxes the following year. It's available right then, and not only that, but it's targeted towards average and lower income households, which means that it's going to be that much more accessible to people, and hopefully will mean that we get not only do I think it's great because I want everyone to have heat pumps, but especially the people that are going to benefit from the most. Like,
the most.
We don't want this to be like a brag about your Tesla kind of situation. We want this to be, everyone's got it.
Well, we think about the most vulnerable homes that we have. Those are going to be the ones that are in that less than 80% median income. Now, when this was originally proposed, this was at a 50% median income, which is a very, very low number. That has been up to, so now we're talking, less than 80% of the median income. That opens up a lot of homes to this, a lot of homes that are very inefficient right now. And so if we are in that less than 80% of the median income for the area, which is different across the country. You have to know what it is for your location. Just do a quick Google for median income, your area for the year. It'll tell you what that is. I know what it is in my area, and it's a pretty decent number. So a lot of people would qualify for that, which means that's 100% upfront discount on $8,000 on heat pump system, $1,750 on a heat pump water heater, which are really coming into play, $840 for electric stove and cooktop, which is a really cool incentive, $840 for a heat pump clothes dryer, $4,000 for a breaker box replacement, $2,500 for electrical wiring upgrades, and $1,600 for different weatherization, including insulations, ventilation. That is a big, big opportunity for folks to increase the comfort of their home. And these are in conjunction with the actual tax incentives as well. Is that correct?
Ooh, I don't know. My guess is that they're not, like, you couldn't claim both.
Sure. Okay. Now, do we have an anticipated rollout for this rebate level?
So I don't know, and I should preface. So I don't have the inside scoop here, unfortunately. I do have the time and the fortitude to dig through things, which is why these slides came out with help from Christian.
Sure.
So yeah, I am not sure. It's probably going to be different for every state because these will be implemented through the state energy offices.
Awesome.
So it's really a wait and see sort of thing. I'll keep you in the loop, Clifton.
Yeah,
and
definitely.
You all can post on LinkedIn and other places.
Yeah, because these are very important for our contractors to be able to
remember
look at
that
systems.
Name, HEEHRA.
Right.
Yeah, HERA.
Use the Google, right?
Well, because we're going to see a lot of changes in equipment pricing now that we're moving into the SEER 2 requirements, which started for our manufacturers for January 1st. So 4 days ago, we started new equipment requirements. And so we're going to probably, most definitely, see some increases of the cost of equipment going into 2023. So this is an opportunity to bring really good incentives for our customers.
Agreed.
Cool. All right. So let's look at some other options that we have. Even besides these, since we don't know exactly when that's rolling out, what other opportunities do we have rolling out across the country that are important things to know for our contractors?
So one program is the New York State heat pump program.
I've heard about this.
Gives quite generous incentives for whole home electrification. So it's been a big push in New York because they just in general have been pushing really hard on decarbonization for a while.
Absolutely. Already cutting off gas connections and looking at electrification on multiple levels.
Mm-hmm. And I should add, so New York State's program is very, very much aggressive towards the whole home electrification, getting rid of the old fossil fuel systems. That is not necessarily required for you to work on kind of electrification goals. You know, for example, I've talked with a contractor in Minneapolis who does a lot of advocacy for heat pumps, and he hasn't installed any all-electric heat pumps. He's only done dual fuel systems because that's the most cost-effective for his customers.
Right.
And his tagline, I think, is never install an air conditioner again. Like if you're going to put in AC, you better put in a heat pump as well, because you're just leaving money on the table.
Absolutely. I mean, if you look at that, if you're just replacing an AC on a system versus a heat pump, which is marginally more expensive, those are big tax breaks.
Yeah. And with the incentives, it's a great setup.
So tell me a little bit about these new requirements in Washington, because I've seen and heard a little bit about this, but I really haven't dove very deep into it.
Okay, yeah. So, and Christian, if you've got more to add, definitely pipe in. I believe Washington State has just recently passed a law that requires all new construction to be built with air source heat pump or some kind of heat pump. And this is really pretty groundbreaking. You think of Washington State, you think of Seattle, which is a little more unless you saw them in the news, typically, a little more of a mild climate where it doesn't get overly cold in the winter. But actually, Washington State is the eastern 2/3 of the state gets really cold. I just moved there from Atlanta, so I experience it. I know it.
Sure, absolutely.
And so these cold climate heat pumps are going to be really critical for rolling out.
So we're talking about new construction residential.
Just new construction, residential,
and commercial as well, I believe.
Okay.
I think commercial was first, and then in November they rolled out this new residential construction.
Okay, very interesting.
So I bought a home in Eastern Washington over the summer, and it has a 2-year-old. It was built 2 years ago, and it's got a 2-year-old condensing gas furnace in it. And I feel like a traitor to the cause because I go out and I talk to people about heat pumps, and I got a gas furnace in my home. But yeah, I'm excited because people aren't going to have to deal with that problem.
Right.
Going forward, yeah.
And Washington has made a pretty hard stance on electrification and degassing on new construction. So very interesting to see that we're adapting that so quickly. Well, what about utilities? What else are we seeing in the utility sector?
So I won't list them all, but there's a lot of utility rebates out there already for heat pumps. It varies greatly depending on the area or the restrictions.
Sure.
But yeah, a lot of incentives for heat pumps. Across the board.
So we need to just reach out to our local utilities to check on heat pump incentives.
Mm-hmm. And what I wanted to get with this whole list is that this is the future. Like heat pumps are rolling out. Sometimes there's a carrot dangling, and sometimes, like in the state of Washington, it's more of a stick kind of situation because it's a requirement.
Requirement by code.
Yeah, you're being prodded in that direction.
Yeah.
Yeah, but that that's what's happening. And yeah, like, so I made this slide to be a little
I love
cheesy,
this.
because, HVAC technicians, HVAC educators play a critical role in this rollout. I know, when I was little, I grew up as an energy efficiency buff, and when I was little, I remember hearing that my grandma would not put fluorescent light bulbs in her house, because when they first came out, she was like, "I'm going to save energy. It's going to be great." She put them in; they were awful because
Yeah.
the lighting quality was poor. We don't want to do grandma's light bulbs for our heat pump rollout. Like,
Sure.
Need it
heat
to be
pumps are
smooth.
not.
Exactly.
Yeah, and we can do it. Like, the technology is there, everything is there. It's a matter of cold climate heat pumps, and well performing heat pumps require a little extra attention, and as the market shifts, that will require additional training, supplement to existing training, and yeah, it's just such an important piece of this puzzle.
As
It
you
really is.
mentioned, um, there's a carrot that they're dangling again in the form of rebates or upfront cost cutting things. But we also have some of the stateside banning in a lot of cities. We've seen natural gas from
Of
being
gas.
installed, forcing us to go
Exactly.
this way. So one way or another, this is coming out, and we need to ensure that it's going to be successful in its rollout. We can't have it stumble out the gate.
Yeah.
Yeah.
Because we hear a lot from different departments of our federal government, and when we look at the importance of electrification, the importance of reducing our carbon emissions, it's something that we have to do. And to be able to do that successfully, we're going to have to unite as an industry. We keep talking about this village of the HVAC industry, how there's not just one area of the industry that can educate enough. We all have to come together and be able to educate these changes and bring awareness to them, because it's going to bring new skills. It's going to bring new education. It's going to change the curriculum that we use in our institutions to be able to prepare technicians for working on this technology. It's not like it's exactly new technology. We've been working with cold climate technologies for a decade or more in these low ambient conditions. Now, we did have an implementation of heat pump technology that really put some sour concepts when we introduced those back in the 1970s. We've really been making them since the 1950s, but in the 1970s and 1980s, we started utilizing heat pump technology a little bit more often. And it was a big change going from, gotta think, back then we were talking 60% efficient gas furnaces that had very high heat output, high temperature rise. So when we went to heat pump technology, yes, it was more efficient, but may not have been as comfortable. And so that's where we come into that comfort advisory, where we're actually educating people on how to make homes and structures more comfortable to prepare them for heat pumps. So that transition of heat pump technology has really changed a lot in this last 10 years, particularly. Yeah, exactly. Better late than never. We are definitely needing the technology. So what we've seen is we've seen heat pumps be able to produce heat at lower temperatures. A lot of that has to do with inverter technology, which we didn't have when we introduced heat pumps. We had single stage compressors with single and 2 or 3 speed fan motors. We moved air. We weren't able to manipulate the boiling point of the refrigerant the way that we do today. So we now have heat pumps that have very high heat capabilities at low ambient temperatures. When we look at our earlier generations of heat pumps, the R22 8-SEER heat pumps that really didn't do us much any good below 40 degrees ambient, well, we don't have that technology. We have a significant increase in technology, and we have the ability to look at system performance and do installations and do service based on how well these systems can perform. So there's a lot of data that we can utilize that we didn't do when we were working on our earlier generations of heat pumps. So how is that changing? How are we looking at installation and commissioning of equipment a little bit differently?
Yeah, so thanks for that, Clifton. Well, just to preface, I know that we've talked a lot about heat pump deployment, right? Deploy.
They're here.
Right? Yeah, this is the way that we're going to reach our carbon goals. This is how we're going to mitigate climate change.
And most of the world has already adapted it. It's not like we're doing something at the same pace as the rest of the world. Most of the rest of the world is inverterized over the last 20 years. We're just now catching up to them because we have these old antiquated ducted systems. So yeah, the technology has been here. We just haven't adapted it the way we were supposed to have.
Yeah. Well, I I really agree with the deploy mentality, right? These are the technology of the future that will get us to where our goals need to be. One of the caveats to that is that you can't have all this deployment without some proper training, without proper testing and commissioning. So there were some recent DOE reports that found that 70 to 90% of HVAC systems, residential HVAC systems, came or had an energy wasting fault introduced to them during the time of installation. Then you can go back to the last slide just real quick.
Yeah.
So 70 to 90% of HVAC systems, of residential HVAC systems,
It's pretty high.
it's it's very high, right? And then on top of that, there was a recent report by a modeling study by the National Renewable Energy Laboratory that found that because of these energy wasting faults and faults introduced during the installation of central air conditioners and air source heat pumps, compared to those systems, if they're installed correctly, we're wasting 9% of energy a year.
Just in installation and commissioning, just setup alone.
Just for residential air source heat pumps and central air conditioners.
I was gonna say, because commercially they do a more robust commissioning of that equipment. It's a lot more expensive. It has a lot more draw
Baseline data.
Yeah, and now we're having to see this trickle into the residential side. The technology's there. It's just that we have to kind of bring it on over.
Yeah, and that's, I mean, you bring up a really good point, right? That I got my start on the commercial side. I was doing HVAC design for a design build firm in the Bay Area. And, you know, they always had tab reports. They always had startup and commissioning reports and whatnot. So if you're going to do that for a large building, why aren't you going to do that for a home? If I'm paying, you know, upwards of $10,000 or $20,000 for an HVAC system, and it's a system that's supposed to last 20 years,
right?
I want to make sure that that system was, you know, properly installed. When you go,
and the technology is there to do it.
It absolutely is here.
Oh yeah, and you know, when you go to buy a car too, you know, how much are you spending? Somewhere around, I don't know. We don't need to get into numbers. It gets pretty high now. But each of those cars are tested when they leave the factory.
Absolutely.
To make sure that they're properly built. So we need to do the same thing while we're in the field creating these HVAC systems. And as you mentioned, Jason, like the technology is already there. So the thing that I'm working on for the Department of Energy, it's called the Smart Tools for Efficient HVAC Performance Campaign. I know it's a lot, it's a mouthful. We like to create acronyms wherever we go. We call it the STEP campaign for short.
Yeah, I like it.
And essentially what we're trying to do is encourage the use among contractors and technicians of these smart diagnostic tools. So where you're doing a holistic system testing, we're testing not only the charge of your refrigerant, but you're also doing some air side testing as well, and bringing those all into, you know, these diagnostic apps that can really perform those tests for you, and make it really easy too. You know, Jamie mentioned some utilities that offer incentives for heat pumps.
Sure.
And those utilities have, you know, what they call quality installation.
They got their requirements. Yeah.
Some of those programs do use these types of tools. And the reason why they've moved to these types of tools was because the antiquated processes of filling out forms with all of the data that you're collecting one by one. With a mechanical device. Yeah.
And they can be pencil whipped as well. They can be filled out to have it whatever you want it to say.
Exactly. So, you know, utilities are starting to use these tools to really make that process as speedy as it can be, and really.
Why wouldn't they? Absolutely. Yeah. If I'm giving you money for a high performance system, you need to validate to me that it is a high performance system. That's all. It's just a business practice that I would follow through. And I think we're going to see a lot more of these expectations and requirements going forward. Because you got to think about this. Installation and commissioning is not new either. Every furnace, AC, and heat pump installation manual that you have ever opened or not opened And the very back of it has installation and commissioning tablet. It has all the data that we're supposed to record on startup and commissioning of any piece of HVAC equipment. We typically are not doing that because it's not been required. So those are the things that we should see changes going forward. So I think smart diagnostic tools are a big, big plus in our industry.
I'll point out too that a lot of those smart diagnostic tools that we're seeing on hit the market too, when we talk about the variance or the the fluctuation of the readings that we're getting when we get into some of these smarter tools, the tolerances are a lot lower, the variances are a lot lower, so they're a lot more accurate than some of the more mechanical things that we've had in the past.
Yes. I mean, we think back about the days that Jason and I got into, installation commissioning. We had mechanical gauges, and we might have had some digital temperature probes, and we had some manometers, or we had a magnehelic, and you got pretty close on your airflow, and you got pretty close on your refrigerant charge, and then off you go. Today's systems are very critically charged, and even just a couple of ounces can significantly change the performance of the system. It was actually brought up by one of our joiners that they were very. One of the statements was commissioning is super important. With the last winter storm in upstate New York, I was worried that the heat pumps would fail because of these reasons. They did survive. A lot of them did well. But when we get into those lower temperatures, those critical temperatures and operating conditions, the critical charge is absolutely important. And the only way to do that is to validate it properly during installation and during servicing.
Absolutely.
So cool. STEP program. I'll make sure we put a link to that in the video so we've got a reference of how to get there faster and encourage people to dive into that a little bit deeper.
Awesome. Thanks, Clifton.
Yeah.
So now we wanted to, we've given you the spiel on some of the kind of the big picture things we think are important about incentives, about heat pump rollouts. We could talk for the next 10 hours on everything else. But we wanted to share with you some resources that are available to help with either training or as a technician for finding
selection.
systems. Yep. So this first one I've got here is the NEEP Cold Climate Heat Pump Database. NEEP, oh boy, that's the Northeast Energy Efficiency Partnership. Is that right?
Yep.
Another good one.
And there's then there's NIA. I think I got those two swapped a bunch. Anyway, but this database by NEEP is a really great resource. They show they have a ton of heat pump units with performance specs at 5 degrees, heating specs at 5 degrees outdoor temperature. So expanded beyond the AHRI catalog so that you can get a feel for the cold climate performance of heat pumps without having to go track down the extended manufacturer data. We don't. That's a big lift. They've got hundreds of data points in here. This is one example here with a Fujitsu unit. I just pulled it off of their website, and it shows the specific unit, the paired outdoor indoor unit, and rated and maximum cooling and heating capacities. For this one, for example, it's got the normal AHRI outdoor temperatures of 47 degrees and 17 degrees, but it also shows that 5-degree heating point. A lot of other units, if they're rated for below 5 degrees, the manufacturer submits this data to NEEP. And so let's say it's rated at -5 or -15 or even -22. They'll submit that. It'll show up. It's a lot easier to find a mini split with that kind of rating right now. But I've seen a good number of split units that also have -5 and -15 ratings on there, and it'll show the minimum rating, the maximum rating, as well as the COP on there, which me being an energy buff, I'm always
Mhm.
excited to see
Yeah.
that.
I base
But
everything on COP.
yeah. But yeah, it's such a good resource.
Yeah, and that is really good expanded data that you can get very quickly, because otherwise, to get expanded data, you're going to have to go back to the manufacturer. You're either going to have to go to the website, go to the actual model, break down into the specifications for it into the extended data charts, if they're even there, or you're going to have to get a manual for a piece of equipment. So now we can look at that expanded heating data, because that's something that we haven't looked at in design as much in the past. Because if we were looking at design of heating, we were looking at gas furnaces that could, supply a steady supply of BTUs at any
At the rate you're
temperature.
losing it, right?
Yeah, so we just did a heat load calculation, and whatever the heating was, that's what we needed. Well, now when we start talking about variable capacity systems, we have to look at what is the capability of our equipment. Not all heat pumps are created equal. There's a variety of different applications. So when we start talking about the expanded heating data, we need to make sure that we're looking at what's going to be needed for our area, because if we're in an area that will hit minus 15 regularly and we have no backup heating source, we're going to have to look only at pieces of equipment that will allow the heating capacities at those minus 15 temperatures, which in the past there have been very few, but they are out there. So that is now starting to develop. Our cold climate heat pump technology is really escalating, and our options are going to be increasing on what equipment we can use. So super cool resource for looking at heating capabilities and different pieces of equipment.
I just wanted to make a point before we got off of this slide that not only are we having to educate technicians and contractors about, hey, these things are here, here's the incentives, here's how they work, but we also have to temper homeowner expectations.
Right.
As far, because they're used to that 120 or 130 degrees coming out of that vent, and you're not going to get that with a mini split or even a split system inverter. So you're going to have to temper their expectations. And the other thing that I bring up, again, looking at this slide, is that when we used to size furnaces, or when we size equipment, we size it at the rate we either lose heat or gain heat. But we never do anything about the rate at which we are losing heat or gaining heat. We just accept that as a fact, and we size a unit based on that rate. And again, what we're seeing here is that it has to be more of when we look at the rate that we're losing heat, there's a lot we can do about that. And then we can, again, scale that back. Don't just accept that as fact. Okay, we're losing X BTUs per hour at this temperature. Let's size a unit to match that. Well, wait a minute. What can we do about losing all that heat per hour? Let's look at why we're losing all of that heat.
Let's reduce that.
Right. And then this becomes doable.
I firmly believe that our HVAC technicians are going to develop into home auditing technicians in the process. And this is scary to a lot of people who have never been in that field, but it's really going to be required, because what if you're doing a size up for a piece of equipment? The homeowner wants to go with a cold climate technology. You do the sizing and there's no piece of equipment that is capable of handling a comfortable thermal balance point for that structure. Well, now we're going to have to reduce our heat loss, so that we can reduce the heat load that is needed, the heat supply off from our piece of equipment. And that is a shift from the way that we have been working in the past. In the past, we just came to fix and off we went. Now we're going to be looking at solutions, which is a really good place to be. Yeah, great slide. Great resource. I'll put a link to that in there so we've got that as well.
All right, so I guess this is me again.
Yeah.
So like I mentioned, the campaign that I'm working on is a STEP campaign. We're trying to get more contractors, more technicians to use these types of tools. We've written this case study on 3 different contractors that have adopted these tools into their businesses. I think that we probably need a few more case studies to really get that business value.
Sure.
Right there are plenty of things other than just, it helps with system performance, but also things like showing your customers, hey, here's a report of all the data that I've collected, and here's it showing that you got an A+ for your system, you get a passing grade. You can, you don't have to trust me, you can trust the data.
Sure.
Right? So there's that part. And then we've also heard a lot about this, kind of great resignation of experienced HVAC techs. And we don't have, kind of the new recruitment to backfill that. These tools really offer a really interesting kind kind of new business model for new companies where, instead of having all of your experienced HVAC techs having to do those the diagnostics, the troubleshooting, maintenance calls, now that tech can be back at the office in front of a computer, streaming the data from the probes and really helping and teaching these new techs on the job.
We're going to have a show on that here in a few weeks or so, talking about how that industry is changing and what that brings as a new perspective. So,
yeah. It's really exciting. It's really, really exciting.
Well, and the tools have changed us.
I've gotten a chance to play with a lot of those tools. Certain manufacturers where we have the wireless technology, we have the apps that are doing things. You don't have to be on site. You can monitor even a lot of the thermostats today, where you can monitor from a distance what's going on in a structure, someone's home. So this is all coming. It's already here, but it's about to go mainstream, and we should be ready to embrace it. It makes our job a lot easier.
Well, and think about what the tools have done for us, just in general. One of the comments that just came in, I use a thermal imaging camera to show homeowner where they are losing and gaining heat. It's super helpful. 20 years, 5 years ago, as an HVAC technician, a thermal camera was like a really cool toy, right? Now we're implementing tools into the industry so that we can develop an entirely new business plan with our HVAC company. There's just no end to where tools are going to be able to make us faster in our job.
Back then, I would only see a thermal imager at a trade show.
Yeah.
That's the only time I ever got to pick one up and hold it back then. Now,
right.
I know 50 different techs that have them in their truck.
Yeah, absolutely.
I will just put one real quick plug in that, from what we've heard from contractors that don't use these tools yet, is that they are looking for training. So what I want to try to do with this campaign is, reach out to trainers that are actually training on these tools for system performance, and really serve as kind of a matchmaking service where any contractor that wants to learn about these types of tools, here's the trainer. So that's what we're shooting for. It's going to take a little bit of time to build that network, but
it's growing. The demand is already there. The opportunities are there. Here in about 5 weeks, we're actually going to have Field Piece on, and we're going to dive into smart diagnostic tools from Field Piece, how to use, implement, ways that we can improve our own efficiency. So as technicians, we become faster at our job, all because of tools and technology. So it's coming. It's growing faster than I think we would have originally anticipated.
For sure. All right, I think we can move on to the next slide. I don't know if this was... Yes. Okay. So this is just another slide about these tools.
Sure.
For anyone who's not familiar, really what it is these wireless digital probes and sensors. It could also include a digital manifold that connects to a diagnostic commissioning smartphone application.
Manometers, meters, reading wattage. I do it all with mine.
That's a good way to bring the younger generation in by embracing this technology. They like gadgets. I'm
telling you. I had this conversation at the conference last year. I was talking to an educator. He's like, how do I get these young guys on the first day of school interested in HVAC? I said, you give them an iPad. You walk over to a piece of equipment that has every digital probe that you have. Give them the iPad and just let them stand there and watch it. And then put some cardboard over the fan. Change a few parameters. Let them see the wattage move. Let them see the refrigerant pressures move. And then start teaching them what that equipment was actually doing. Show them the technology first, and boom, now you've got it.
Yeah, there's a lot of them out there. And again, the younger generation is quick to embrace technology,
they love it.
And they love gadgets. So again, if this is the future of the industry, we can draw in a lot of the younger generation by, again, embracing this technology.
Exactly. And as instructors, I know Jason and I are right here with you. It's hard to teach something that you didn't grow up on. It's hard to teach something that you didn't use on your own. And that's why we're here. That's why we're in this village, is to bring people in, because we're all learning at the same time. Technology is moving faster than any of us want it to. But the reality is it's moving very fast, and we have to keep up with it. And that's what we're doing. We're just talking about the changes in the industry. We're building the resources. We're getting the right people in the right place with the right information so we can all do this easier together. So I'm excited about it. I like change and I like technology. So this is fun for me.
Yeah. All right, I think we go to the next slide.
All right. So this Yeah, this next one is more oriented towards trainers, instructors who are doing this kind of heat pump or other emerging technology
Yeah.
training. So this is the Building Science Education website. It's a Department of Energy site that is, our goal is to be a centralized source of free open source materials that you can use for training HVAC technicians, or the ultimate goal is for just overall building science education. So people all through, building managers, technicians, facility operators, engineers, architects, etc. Everyone. So this website has training materials, and you can actually flip to the next page here. It's got an example.
Oh, yeah, there we go.
So this is a very tiny view of a bunch of the different new HVAC modules that we've added, oriented towards heat pumps, cold climate heat pumps, retrofitting fossil fuel systems over to electric heat pump systems, dual fuel systems, smart diagnostic tools. There's a lot of really great training materials. So this is meant for an instructor. You can download lecture notes. There's learning objectives, lecture notes, problem sets associated. If you make an account and get signed up as a professor, you can get access to the answers to the problem sets. There's also other resources like handouts, PowerPoint slides,
Video links,
videos. Yeah. So it's a great resource. I think I'm allowed to say that because I'm the main person that put it together.
That's right.
Oh, I was in the classroom for 15 years, and I've had a chance to thumb through this, and I can tell you, as from one educator to another, that there is a lot of really good material here. There's a lot of resources. It's well thought out, and if you're going to move forward with this in your program, that this is a great resource that you don't have to spend a lot of time on. It's already there. It's already prepared, and there's a lot of stuff put together, categorically separated, as you can see there, from one instructor to another. This is a great resource.
And it's not just on the heat pump technology. As you can see, there's things like duct leakage training. One of the comments that just came in from Keith. Thank you, Keith. That is a really good point. We talk about changes in technology and the controls and the equipment, but what about the old ductwork, and what about the designs of the systems? That is also having to change as we move forward. We've already seen changes in the way we design equipment because of things like the M and M1 testing, which is what's making the equipment move from SEER to SEER 2. Our original expectations is that we had low external static pressure on our system designs, and the reality is we don't. That all ductwork is designed not as efficiently as it should, or it's had other things added. It's had different registers, it's had different filters, it's had things that's changed the airflow. So understanding ductwork and understanding airflow in our systems is critical as well. So there are additional resources like the duct leakage testing and a variety of different applications out there to get better at understanding the envelope, because the ductwork is absolutely part of our envelope.
I would say the ductwork in most homes was designed and put in for a system that was designed 50 years ago. And we're hooking up a modern system from, say, 2023 today, super high capacity, super high efficient, to a duct system that was, again, designed for a system that was at best 60% efficient.
Exactly. Not designed for the air filtration that we're utilizing today, not designed for secondary heat exchangers, and not designed for microchannel evaporators. And a lot of things have changed, and it is about becoming better at what we do. If we think about what has changed for a technician in the automotive industry, 20 years ago, you might have been an automotive technician that had a manual set of gauges, and you had a voltmeter and a fuel pressure tester, and you could work on a majority of the vehicles. You can't do that anymore, can you? You're using things like OBD2/3 testers. We're analyzing systems with digital components, and we're using those to pinpoint laptops to pinpoint our problems. That's happening in our industry. It's happened in our commercial industrial for decades. It just didn't make its way into the residential the way it is now. So the expectation is that we are going to have to become better technicians, better contractors, and we're going to have to prepare ourselves for the equipment that is here, not just coming, is already here. And so now we're going to see incentives for us to go with the technology. So what's going to happen when the homeowners start utilizing the incentives? We're going to be forced to install and work on these things. So that's what we're here for, is to prepare you.
Mm-hmm.
Awesome.
So I've got one more resource that I wanted to share with you all. This is, and I titled this as oriented towards everyone.
Mm-hmm.
So this is the Building America Solution Center, which is also a Department of Energy site. And I can't take credit for this one, but it's also administered by folks here at PNNL. And it's just a treasure trove of resources relating to building efficiency, to building performance, and to building resilience. When you're Googling random like home efficiency related things, often the top 1 or 2 results is actually from the Building America Solution Center.
I've seen a lot of it popping up in my own searches. So yeah, there's a lot of data out there.
Yeah. And you can flip to the next page. I've got an example of one of their guides. So the way it's structured, they have these guides on different topics relating to buildings. And so this is the one on traditional split heat pumps.
Systems. Mm-hmm.
And it's got you can see sort of in the middle there's tabs. So the first one that's open right now is scope, but there's a scope that talks about, a big picture of what the system is. There's a description, which gets more detailed. Obviously, you all don't need to read this one. But, things on what are the successful attributes of a system, what do you have to consider in different climates, and some code-related things, some sales pitch.
There's a lot of tools there.
Ton.
Yeah. Yep. And it's great for DIYers. It's great for home remodelers. Good for HVAC technicians that are looking into HVAC efficiency type measures, as well as overall home efficiency. So they've got a lot of really great resources on windows and air sealing and so
it could be a resource for a homeowner.
That's what I see. And that's the part that most of us don't think about is, in the past, we focus a lot on, what are the options? We'll give some, different options for equipment to the homeowner. But in the past, the homeowner has not really been as educated as what I anticipate they will be in these next couple of years. This year, particularly this spring and summer, when the homeowner gets their first estimate on replacing equipment, they're going to step back and they're going to do some research to see what's happening in the industry. And these are going to be tools that will help with that, because it's a worldwide effort. We're starting to see a lot more advertisements for, emissions reductions and greenhouse gases and how we can contribute to the reduction of greenhouse gases. As people start educating themselves, they're going to see the opportunity in using incentives and using tools to do the research to find what works best for them, and looking at all of the options that they have for, utilizing these resources the best that they can. And I hope that these kind of resources really change the perspective for homeowners looking at their options and have an understanding. Because a lot of times people buy equipment just because they've been told it's the best system for them. And I can vouch that I have a brand new home that has a high efficient 14-series air conditioner on it.
I would say that, Uncle Google has made the homeowner just as aware of what's going on in our industry as the contractors and technicians are, that the information is out there, easily typed into Google, and you get a result like this. So the homeowner, contractors should expect a more informed homeowner when they go out to do a replacement.
Yeah. And I
Something
hope
we're
they
not
do.
used to. Yeah.
No, we're not. And there's a really good comment comment/question that just came in from Keith. Is there an industry certification that would allow a homeowner to know a specific individual or company is educated in the material that we're discussing? Also, would it be economically feasible to install ductwork allowing to meet the standards that we were talking about? Those new standards, Keith, are there because we were doing poor jobs to begin with. So all of the SEER 2 specifications that we see coming out on equipment, that is simply because the original standard was for a 0.1 inch static on our duct design. Never happens, does it? So the SEER 2 is just simply saying, okay, there's no such thing as 0.1 ductwork out there. Let's re-rate all this equipment at a 1/2 inch of static, which is manageable, and then we'll see how well the system performs at a 1/2 inch versus the 0.1 inch that it originally was done for. So it was in response to poor ductwork that we went from SEER to SEER 2 requirements. And as far as a national certification, I sure hope so someday.
There are a lot of industry certifications out there.
There are.
Not to toot our own horn, but here at ESCO, we do have a lot of certifications in different areas, so, specialty certifications, but there are a lot out there.
Yes. No standardized, and there may never be a standardized, but I hope that we see more certifications and more acceptance from the homeowners to be looking for certifications. Because, yeah, it could be specialized. Because if we have a technician that's really good on, say, a modulating gas furnace, are they any good at a inverter, heat pump, cold climate?
I have somebody that can put in a mini split, but do they know how to work on ductwork? Right.
Exactly. So, yeah, I see things get more specialized. When you take your vehicle to go get it worked on, there was a time when one mechanic worked on everything. Now you have mechanics for different components. You have emissions component, there are emissions technicians. You have drivetrain technicians. You have suspension technicians. You have controls and automation technicians. And I see that happening a lot more in our industry. It already does in the commercial and industrial side. Why wouldn't it in the residential? We're just simply tailoring our equipment a little bit differently because it's more advanced. So our technicians are going to have to be more versed. Are there going to be technicians that want to learn all of it? Oh man, I hope so. That's what we're here for. So
it's that tree, Clifton. Remember the tree with all the branches coming off? We have an HVAC tree, and there's so many branches, and each different branch represents a different area of the industry.
I can't wait for you to scope that out and where people can see that a little bit clearer. Because if you think about the HVAC tree from 30 years ago, it had a couple forks, right? It had residential, commercial, maybe chillers, and then you had a refrigeration. Because refrigerator, they just got everything dumped on them. That if it wasn't AC, it was just over here, right? So as we have gotten further along in our technology, our tree, the HVAC and refrigeration tree, has grown. And we are now more into the comfort level. We are going to have other branches of our tree that falls in our umbrella. What about a heat pump water heater? Who's supposed to work on that? Is that an HVAC person that knows refrigeration cycles? Or is that a plumber who doesn't own a set of gauges and doesn't have a refrigeration license? Ah, that's something to think about, isn't it? We're going to see these technologies coming into the residential sector, and we're going to have specialized departments. Look at blower door testing that's now becoming code in many places around our country. Who's going to do that? Not the electrician, not the plumber, not the home inspector. Who would make sense to that? That's HVAC, it's ventilation. So our tree is definitely developing, and it's a good time to be in the industry because we have a support network unlike any other time in the past. When we were making transitions back in the 90s, when we were doing like CFC transitions, we didn't have a lot of people coming to the industry going, hey, what do you need from us? In today's world, we have PNNLs, we have EPAs, we have DOE, we have manufacturers, we have a variety of different representatives of our industry all coming together to try to help us all be more prepared and make wise decisions and educate ourselves better. I think it's a beautiful place to be myself. All right, any questions? Let's get to the end here. Let's make sure we've got some resources too. So if anyone has any questions they want to bring in, remember, that's why we're here on Did You Know Show. This is a live opportunity. We're not all recording this, putting it together, and just throwing it out here for you to watch. We are all right here to answer questions for you. So if you have some, throw them in. And we want to make sure that you see some of the resources that we have. We've got the incentives at energy.gov. I spent a lot of time there. That whitehouse.gov, I've been using that resource a lot more here recently. They've been spending a lot of time explaining things, especially from the Inflation Reduction Act, So each one of these will add links into the videos at the end. I'll make sure that those are accessible to you. And man, it's a lot of fun. I'm glad we had the opportunity to do this today. All right.
Yeah, this is a lot of fun.
This was a lot of good information that I
Yeah.
think people really need.
Yeah, I do too. And I'm sure we'll have more questions. It's interesting because I've seen the counts of people grow as we progress through here. You've seen some dive off earlier and then must have came back and went, wait a minute. What did I just hear? There's a lot of things that need to be digested a little bit differently. So we'll give it just another minute. If anyone has anything else that they would like to chat about, Jason, got any kind of questions you want to throw at Christian or Jamie?
I'd like to thank them, one, for being here,
boy.
and two, thank them for the resources that they're providing here. This was awesome, beneficial, educational, everything I hoped it would be.
Yeah, this is some good stuff.
Glad to hear it. Yeah.
All right. Well, thank you guys so much for joining us. And we're going to wrap this up. And we will see you all next week on Did You Know? The ESCO HVAC Show.
Take care.
Thank you for joining Did You Know? The ESCO HVAC Show. Brought to you by the ESCO Institute and HVAC Excellence. Our mission is to bring the top educators of the industry here for you in a live, unique experience so that you can join us from multiple social platforms, all with the opportunity to ask questions, to be involved, and to learn about the things that are changing in our industry as they are changing. Subscribe to our YouTube channel to get notifications when we go live every week. Are you an educator looking for resources to be the best that you can be? Man, you're in the right place. And we invite you to come join us at the National HVACR Education Conference, where we bring all of these guests and many more, along with manufacturers and different organizations of the trade, so that we can all be in one place at one time and gather this information to make us better together. How do you learn more? Go to escogroup.org, select HVAC Excellence, and then the conference. I look forward to seeing you again next week on Did You Know? The ESCO HVAC Show.